A, B and C are three spheres. The volume of sphere A is 125 centimeters cubed. The volume of sphere B is 27 centimeters cubed. The ratio of the radius of sphere B to the radius of sphere C is 1 to 2. And we need to work out the ratio of the surface area of sphere A to the surface area of sphere C. Okay, so firstly, we're going to be having a look at the ratio of sphere A to sphere B. Now we know the volume of sphere A and the volume of sphere B. So the ratio of the volume is going to be 125 to 27. Because A is 125 centimeters cubed and B is 27 centimeters cubed. So now I'm going to have a look at length. Now a little trick to remember what to do here is we need to look at the units. So now the units for volume, well, that's been used in the question. We've got centimeters cubed. So sticking with centimeters, our units for length are going to be centimeters. So how do we get from here to here? Well, that's with the cube root. So that's what we're going to do. I'm going to take the cube root of 125 and the cube root of 127, giving me a ratio of 5 to 3. And in this case, when we're talking about the length, we're sort of thinking about the radius. So now we can look at the ratio B to C. So again, like I said, when we talk about the length, we can think of that like the radius in this case. So we're told in the question that the ratio of the radius of sphere B to the radius of sphere C is 1 to 2. So we can fill that in on our table. So now I've got two separate ratios. I've got A to B and B to C. But my goal is to look at the ratio A to C. So we need to get B to have a common value. How can I make B the same? Well, how do I get from 1 to 3? I'll multiply by 3. So to keep the ratio equivalent, we need to do the same to B here and C here. It's going to multiply the 1 by 3 and the 2 by 3, giving me the ratio of 3 to 6. So this is completely equivalent to this, because we've just multiplied everything by 3. And I can keep this the same. So I'm just going to bring down 5 and 3 here. So from this, what we can now do is look at our ratio from A to C. Because the B's here are the same value, we've now determined that the ratio of the length between sphere A and sphere C is 5 to 6. However, the question says we need to work out the ratio of the surface area of sphere A to the surface area of sphere C. So again, to do this, we're going to use our little trick. So the units for length that we're working with in this case is centimeters. So what does that mean the units for surface area are going to be? Well, the units for volume were centimeters cubed, but here we're talking about area, so it's going to be centimeters squared. Well, how do we get from centimeters to centimeters squared? We square it. So that's what we're going to do. I'm going to do 5 squared, and I'm going to do 6 squared, leaving me with a ratio of 25 to 36, which is our final answer. So you get 1 mark up here for finding the length ratio between A and B. We then get a second mark for getting a ratio between A and C. Then we get the final mark for getting down to the correct surface area ratio between A and C of 25 and 36.